Hi, also, let's get started. Let's talk about net ionic equations. So we've talked about this idea of precipitation reactions, solutions, what makes a solution, the solute versus the solvent. We'll take it a step further and talk about precipitation reactions. So we've talked about 5 different types of reactions: the combination, the decomposition, single displacement, double displacement, and combustion. Precipitation actually is one reaction that falls under one of these things: double displacement reaction. So you can read this. I'm not going to spend time kind of reading through this, but the big idea here is that when a reaction happens, there are things that can form. So a precipitate forms, that's a precipitation reaction. We can form gases, we can form liquids, we could also have no reaction, okay? And so specifically, we're looking at precipitation reactions for this, and a precipitation reaction is usually a double displacement reaction, okay? That forms a precipitate. So double displacement, double replacement, exchange reactions, metathesis reactions, these are all the same thing. Essentially, we're switching partners, okay? So A plus AB, CD, A goes with D and B goes with C to form a new product. And usually, typically in order for it to be a precipitation reaction, a solid must form, okay? So on the particulate level, so looking at it in terms of what's going on with the particles, here's what's happening. I have 2 clear liquids, so this liquid here and this liquid here, and when they combine, they form this solid, and that's what this chemical reaction is showing. Okay, other ways to look at this, so I have ions in here, and when they combine, so A and X, that's my first compound, B and Y, my other compound, when they combine and switch partners, I form AY, which is aqueous, and then Bx, which is actually a solid. So this is a precipitation reaction. Another way to look at this, so 2 clear liquids coming together to form my solid, precipitation reaction. If they all stay aqueous, then no reaction has happened. So in order for me to determine if a solid is going to form or not, I need to know my solubility rules. And that's why, again, go back, make sure that you are reviewing those solubility rules. You understand what the solubility rules mean, when something will form a solid and when it would stay aqueous or not form a solid, okay? And in this case, forming a solid is the same as a precipitate. So this right here is what we would call our precipitate. Okay? All right, so solubility rules, review. It's important for you to figure out whether or not you would form a solid or not. All right, so there are 3 types of reactions, equations that we can write. Molecular equation is one that we're familiar with. We've done this so far. That's all we've written. And it's essentially taking your compounds and switching the partners. Okay, so calcium nitrate reacts with sodium carbonate to give me sodium nitrate and calcium carbonate. Writing it out this way is my molecular equation. I'm writing out the complete chemical formula for each of these things. Okay, I can then write my total or complete ionic equation, which essentially breaks up everything that is aqueous or soluble. Okay, so if I look at my reaction and I have something that's aqueous, I break it up into its ions. So if we go back here, this is aqueous, aqueous, aqueous. Solid will stay together, but I break everything else up. And so that's how I have my calcium and my nitrate, sodium and carbonate. Sodium carbonate stays together because it's not aqueous, but sodium nitrate breaks apart. So this is my complete or total ionic equation. I'm essentially breaking apart into ions everything that is aqueous in solution. If you look at this, you'll see that I have nitrate and sodium on both sides. We call these spectator ions. Okay, so if I have ions that appear on both sides of the equation, I call them spectator ions. They're essentially just spectating because they don't take part in the reaction, which is why they say as ions. Okay. In a precipitation reaction, all your reactants should be aqueous and so should be written as ions. Okay, so they should all be aqueous to form your precipitate. The third equation is your net ionic equation, and you get this by removing the spectator ions. So if you think back to our complete or total ionic equation, we had sodium and nitrate on both sides. These are spectator ions, and so to write our net ionic equation, we take out these spectator ions, and so for that equation that we've been working on, Here is our net ionic equation. No spectator ions in there. Okay? If every single ion or every single ion is a spectator ion in a reaction, we would say that in a precipitation reaction, we would say that no reaction occurs because the ions that we start with, we're ending with them, no reaction has happened. Okay. All right. Oh, no, this is starting from the bottom up, but that's okay. So your molecular equation, that's what that looks like. The total ionic equation, again, break up everything aqueous breaks up and the solid stays together. This would be my net ionic equation, right? And in this case, my spectator ions are ions that occur on both sides. So potassium and nitrate are my spectator ions. Okay, here is an example. I would go ahead and pause this so you work through it and make sure that you understand what's going on, okay? I'm gonna work through it now. So take a second, pause, work through this and make sure you get the right answer. Okay, hopefully you've paused. Welcome back. The net ionic equation for this, so this is aqueous, this is aqueous, this is a solid, so it's going to stay, and this is aqueous, so we're going to break that up. So I'm going to first break everything up to write my total ionic, and then take out my spectator ions. And so in this case, it's Pb2 plus aqueous, plus the nitrate, 3, 2, I have 2 of that, plus 2 things of sodium, aqueous, and 2 things of chlorine or the chloride ion aqueous to give PbCl2 stays together because it's a solid, 2 things of Na plus aqueous, and 2 things of NO3, 2 minus also aqueous. In this case, my spectator ions, nitrate on this side, sodium on that side, and so my net ionic equation is Pb2 plus 2 things of the chloride ion to give me PbCl2. It's a solid. Okay, and that is my net ionic equation right there. Here are some other things. Make sure that you're able to work through this. Again, I would go ahead and pause it and work through it to make sure you get what you need to get. Okay, so silver nitrate combines with sodium chloride, I get AgCl. I know this is a solid because of my solubility rules. NaNO3. And this is aqueous again because of my solubility rules, and we're good. Okay, the net ionic equation here would be Ag plus aqueous and Cl minus aqueous to give me AgCl solid. Okay, and potassium sulfate reacts with barium nitrate. I get potassium nitrate, which is aqueous, and barium sulfate, which is a solid. I know this because of my solubility rules. That is balanced, and my net ionic equation would look like that. Okay, calcium hydroxide combining with sodium phosphate will give me calcium phosphate, which is a solid, again, solubility rules, and sodium hydroxide, which is 6, 2, 3. Yeah, I think we're good. Yep. And sodium hydroxide is aqueous again because of my solubility rules, and the net ionic equation here is Ca2 plus and phosphate PO4 3 minus 2 things of that to give me Ca3 PO4 solid. Okay. All right. Pause here, look at these reactions and figure out what's wrong with them. These are common mistakes that are made by students. Hopefully you don't make these mistakes. So go ahead and pause this right here, read through, make sure that you understand what's going on. Pause. Okay, welcome back. And so for this one, remember when we write ionic equations, we always write the lowest things possible. So these things are not okay. It should be KOH and KCl, just KCl. Okay. For the next one, it is not balanced. Oh, right here. So OH is a polyatomic ion that should be together when you put the 3, okay? So again, that 3 is for the OH, not just by itself. Here, I'm missing a 3, and it's not balanced, right? I have 3 things of Cl here, I haven't balanced this. And for this one, I'm missing states. So this should be aqueous. This is a solid, this is a solid, and this is aqueous. Okay, so don't forget your states. Yeah, mistakes that are typically made, so make sure you don't make those. Alrighty, y'all. I will see you later.